This matrix indicates a homogeneous the representation of a 2D transformation operator, representation of 2D transformation operator in three-dimensional homogeneous coordinate system, and we are generalizing the parameters this A, B, C, D, M, N, this P, Q, S, and these ABCD parameters are mainly responsible for this scaling, hearing, etc. And these two parameters is responsible for projection, and these two parameters is mainly responsible for translation, and this parameter is responsible for overall scaling. So next we have to discuss about, so up to this time all the operations we have done about the origin. So we are rotating about the origin, we are translating with respect to that origin. Okay. Likewise, suppose in the screen we are having a picture like this. We are having a picture like this, and there is an arbitrary line, and above that there is a triangle. So we have to reflect this triangle. We have to reflect this triangle about this line. Okay. Up to this time, we have studied the reflection about this x-axis as well as reflection about y-axis. So for that purpose, what we have to do? Okay, that is the figure indicating. So the step is that first of all, you check in how much distance from the origin is the end point of this one. Okay, from this origin, what will be the x coordinates? What will be the x coordinate? What will be the y coordinate for this particular endpoint? Okay, so you identify those points and you can do a translation with the negative values. So on doing that translation, all the things will come to this origin. That is, this endpoint will come to this origin. So we have to do a negative translation. After that, we can do a rotation. We can do a rotation. Okay, that is, we can do a rotation so that this line should be parallel to this x-axis or parallel to this y-axis, whatever may be. So here we have to we are rotating that line parallel to x-axis. After that, as the line is coinciding with this x-axis, we know that simply we can do the reflection about x-axis, then do the reflection about x-axis, then you will get a reflection about this x-axis. You will get. After that, again you have to rotate back, and again you have to translate that. These details we can see in this figure. So we have to translate that entity, that is line, along with the triangle to the origin. So translate to the origin. After that, we have to do the rotate. This one we have to do the rotation, and after that we have to do the reflection about x-axis, and after that we have to do the rotation back, and after that we have to do the translation back. In the textbook also it is available. It is reflection through an arbitrary line. Okay, reflection through an arbitrary line. This is the line. This may be the triangle, and this will be the reflected. This is the desired one, desired things we have to do the operations. Okay. So here you have to find out the offset distance. Okay, you have to find out the offset distance, and with respect to that, you have to make this line come to this position, that origin. This line should pass to this origin. Then after that, you have to do that rotation. So here it is rotated. Then after that, you have to do the reflection. Then you have to do the rotation back and translation back. In the 3D transformation, actually the 3D transformation operator will be a 3x3 matrix. But in order to represent that 3x3 matrix in homogeneous coordinate system, it will be a 4x4 matrix. It will be a 4x4 matrix. Then in this general form, the first 3x3 matrix will be responsible for sharing, then scaling, rotation, reflection, etc. This 3x3 matrix. And this column, this matrix, that is, it's a, this is 3 by 1 matrix, this one, PQR, that is a projection representing, if you are putting some values there, it will give the projection. And this is element, this L along x direction, M along y direction, N along z direction. This element are representing the translation. And this matrix, otherwise this 1 by 1 matrix, this is for overall scaling. This is for overall scaling. Okay. And in the 3D transformation also, we are having three axes. Therefore, we are having rotation about x-axis, rotation about y-axis, and rotation about z-axis. Okay. And if it is rotation about x-axis, see, if it is rotation about x-axis, you just see the first row will be 1 0 0 0 and first column will be 1 0 0 0. Okay. And here it is 0 0 1. So cos theta sin theta minus sin theta cos theta. Here it is 0 0 1. This is the matrix for rotation about x-axis. And you see, while we are writing this rotation about x-axis, first this will say this is this representing x. Therefore, that will be 1. And if you are considering z-axis, see, in the third row, and this third column, this value will be 1. Okay. Then cos theta sin theta minus sin theta. Y-axis, you see this value. Okay. This value will be 1. Then 0 1 0 0, and here is 0 0 0, and here it is cos theta sin theta cos theta 0 0 1, and for the y rotation about y, this value will be negative. That you have to know. So therefore cos theta minus sin theta cos theta. Okay. So these are the things. This is the rotation about y axis. Rotation about y axis. Okay.